Okay, so let's solve the following problem, which states use the squeeze theorem to find the limit as x approaches 0 of x squared sine pi divided into x. Okay, so squeeze theorem. What does the squeeze theorem consist of, or how does it work? The squeeze theorem works when we have three functions. Let's call them g of x, f of x, and h of x. The theorem tells us that if in a given interval we have that g of x is less than or equal to f of x, and this at the same time is less than or equal to h of x in a given interval. It doesn't have to be in the whole domain of the functions, but just in a little interval that contains the value we're interested in this case, the value of the limit. If this is true in a given interval that contains a, right, then if the limit, let me write it here, the limit as x approaches a of g of x is the same as the limit as x approaches a of h of x, then, and let's say this will be equal to a given number L. If they are both the same, then the limit as x approaches a of f of x will be L as well. It's called the squeeze theorem because both functions g of x and h of x are squeezing f of x in a way that all the three limits will be the same. So that's what we need to get. This is what we need to find. Two functions, g of x and h of x, such that they will be greater than or equal to our given function x squared sine of pi divided into x in the interval or in an interval that contains x equals to 0. So let's try to figure it out. And we can figure it out by simplifying the problem, right? We can start with the function sine of pi divided by x. No matter what angle you have inside the sine function, no matter the angle, it is always true due to its range that the function will always be greater than or equal to -1. And it is always true that the function will always return a value that is less than or equal to 1. You cannot get any value that is greater than 1 or that is less than 1 from a sine function. That will just not happen. No matter what angle you have, that will never happen, right? So, we know that this inequality is true. We can modify this inequality in a way that we end up with the function we are interested in. For this inequality to be true, we need to multiply all the parts of the inequality by the same thing, so it remains equivalent. So in this case, I can come and multiply each part of the inequality by x squared. So I have -1 times x squared, which is less than or equal to x squared times sine of pi divided into x. Which happens to be less than or equal to 1 times x squared. Right? I multiplied each part of the inequality by x squared. So the inequality should remain equivalent, right? So in this case I can come by and simplify the inequality to get minus x squared, which is less than or equal to x squared times sine of the function, sine of the angle, I mean pi divided into x, which should be less than or equal to x squared, Okay, great. So this is our inequality. This function we have here will be our g of x. So let's say that g of x equals minus x squared. Let's also say that f of x equals x squared times sine of pi divided into x. And let's say that h of x is equal to x squared. Okay, so we have our three functions. This inequality is met. So let's figure out the limits of g of x and h of x. So let's see what happens. So let's find the limit as x approaches 0 of the first function g of x, which would be minus x squared. This limit can easily be solved by just substituting this x equals to 0 into our function, so we get minus 0 squared, right? So this limit as x approaches 0, of the function minus x squared equals 0. This is our first answer. This is the first thing we need to keep in mind when solving this problem. So let's highlight it. So there we have it. Okay, so now let's find the limit of the next function, h of x, which is x squared. So let's say the limit as x approaches 0 of x squared. This can easily be solved too by substituting x equals to 0 in for x. So we have 0 squared, which we know that it's just 0. So now we know that the limit of x squared when x approaches 0 is just a 0. This is the other answer that is important for us. So notice something. Notice that both limits, right, the limit as x approaches 0 of minus x squared is the exact same thing as the limit as x approaches 0 for x squared, positive x squared, which both are equal to 0. Therefore, the limit as x approaches 0 of our function x squared times sine of x or of pi, I mean sine of pi divided into x will be equal to 0 too. And this is our answer. This is how we solve this problem by using the squeeze theorem. Since the two limits as x approaches 0 of the upper and lower functions are the same, then according to the squeeze theorem, the middle function should be the same. So this function, the limit to this function is equal to 0. And we can appreciate that in the graph of the functions. Notice the graph of the function. Let me move this a little bit over here. Okay, so this red graph will be the graph for minus x squared. the blue graph will be the graph for x squared, and notice that the middle graph is the graph for x squared sine pi divided into x. And as stated before, the function will never get to be greater than the other two functions, so they are squeezing the middle function in such a way that its limit approaches 0. Notice that the function is not defined for x equals to 0, but the other two functions are, and they are squeezing it. They are squeezing the middle function, so the limit approaches 0. Let me get rid of the other two functions so you can see how the original function approaches 0. So let's see, let me get rid of the other two functions. This. And if we wish to approach to 0 from the left, we see that the closer we get to 0, the closer our answer or our function returns 0, even though the function is not defined for x equals 0 when approaching from the left, and from the right the answer returns a value of 0. So that will be our answer. Now, I hope this was helpful for you. Remember to follow me, to click the subscribe button, and click on the like button too. And if you need any live tutoring, you can contact me. You can click on the link on the description, and I'll be happy to work with you.